Howdy, AP PreCal. It is Miss Kosh. I want to work through Mr. Passwater's notes for 1.6. I'm not sure that I've worked his 1.5 notes. I will go check my YouTube channel, and if so, I will put I will do that too. But okay, I teach this slightly differently, but let's go with what he has here. The end behavior of a function describes how a function, as it moves infinitely, how a function changes. How a function as it moves in. Yeah, I'm not sure what word he wants here. The end behavior of a function describes how a function blank as it moves infinitely to the right and left. Well, what we're talking about here is my function's either going to keep going up forever or go down forever. Okay, and so that's the end behavior, that as I go, like there might be all this interesting stuff kind of in the middle, but as I get farther out to the ends, what's my function doing? In other words, the end behavior is what happens to the values of y as x increases or decreases without bound. AP likes that notation, that terminology without bound. So we're gonna try and use that. It's not in my nature necessarily, or it's not, I can get there, but I don't always use that. That's not always my language, but here we go. We're going to work on that. So here is what we talk about. The left end behavior is what happens as the x value decreases without bound. The y value of f of x is, what is it doing? Okay, so in this case, what we will say, this is limit notation, and it becomes a huge part of calculus, and they're introducing it in PreCal for you. So it's the limit as x goes to negative infinity of f of x is how we read that. So that's saying as x goes to negative infinity, as x is going this way, what's my y value going to do? Over here, the right end behavior, the limit as x goes to infinity of f of x is how we read that. and using this increasing or decreasing without bound language, it would say, as the x value increases without bound, the y value of f of x increases or decreases. Okay. Or we might say goes to positive or negative infinity. Okay, let's see. So on this one, he's got arrows here going down and arrows here and here. Okay, so on this one, the left behavior verbally, as the x value decreases without bound, the y value goes to positive infinity. So as we go farther and farther as our x values get smaller and smaller and we get more and more negative, the y values are getting bigger and bigger and bigger. The limit, so this is saying the limit as x goes to negative infinity of, we're going to call this f of x, is equal to positive infinity. The right behavior is saying as the x values increase without bound, the y values of f of x go to negative infinity is how I would say that. But most of the time, they're not going to make you write that. They're going to have you, they might have you write the limit notation. I can't imagine they're going to have you write this notation, but they might expect you to interpret it from multiple choice. So that you should be prepared to do. And this is going to go to negative infinity. And that's the limit notation that we want to write. And this x is kind of underneath. Sometimes it's directly underneath that. Sometimes it's kind of between the two. But that's what we're looking at. This one, the limit, let's just do as x goes to negative infinity of, we'll call this one g of x, what the heck, of g of x is equal to positive infinity. And then the limit as x goes to positive infinity of g of x is also equal to positive infinity. Okay, oh, and I bled through. Okay, let's try just one piece of paper. So now it says sketch a polynomial function with the following behaviors. So I'm going negative, negative. So I'm going to ultimately end up going down. So who knows what's happening? It doesn't tell us. There we go. That would work. If this one we want to go negative, negative, and then positive, positive. So then I can do something like I can do all sorts of crazy things. I don't know. Whatever my polynomial does, it looks something like that. Ultimately, what do we care about? We care about these. As x goes to negative infinity, the y is going to go to negative infinity. The limit as x goes to negative infinity of g of x equals negative infinity. I'm sorry, you couldn't see that. There you go. Okay, for polynomial equations, it is easiest to find the end behavior of the right side, this side. So what I like to think of is if we end up going like this, if we end up going up, ultimately then we have a positive leading coefficient. If the other side was also up, then it's an even degree. If it's also down, it's an odd degree. Okay, let's see. The right side goes up if the leading coefficient is positive. Then it goes down if the leading coefficient is negative. The left side goes in the, the left side goes in the same direction as the right if the degree is even, and it goes in the opposite direction of the right if the degree is odd. Okay, determine the end behavior for the following polynomials. Limit notation is not necessary. Oh no, I want you to practice limit notation. Let's do just a few of them in limit notation because I'm not a nice person. Ask my students. Okay, let's do the ones that are a little more interesting. Let's do E and F. Okay, so on this one, on E, I see that it's an odd degree. Its largest exponent is 5. So this is odd, and it's and negative. Okay, so that means the limit as x goes to negative infinity of k of x is one side. The other one is the limit. Can you see everything I'm doing? Yes. X goes to positive infinity of k of x. So this one, if it's odd and negative, that means it's ultimately going to be going down, and odd means it's going to have done the opposite thing. Oh, you couldn't see. So it's going to do who knows what in the middle. I don't really care. But as we go to negative infinity, it's going to go to positive infinity here. As we go to positive infinity, it's going to go, as the x goes to positive infinity, the y is going to go to negative infinity. Let's look at F. When I expand this one out, I see that I have 1, 2, 3 x's, though that gives me an x cubed. And we think, okay, so, well, here's the trick. What we should do is we should think of this m of x could be written as a 2x times an x minus 1, that's a minus, times a negative 1, and then I can factor out the negative 1. This becomes a positive x plus, I lied, minus, did you catch that before I did? Minus 6. So this helps me see the 0 a little bit more clearly. My 0 is still 6, but this will show me that my leading coefficient is going to be negative. So this is odd and negative again, which is going to do the same thing that we just saw. So I could come back to this equation and just change all these to m, or to those limit notation, and change those to m, and we're good to go. Let's do an even one on C. If I expanded that out, it's an even degree. And it's, but if I multiply everybody through, my leading coefficient is going to be negative. So it's even and negative. That's a G, pretend. That looks terrible. So the limit as, you know what? Let's call this something else. Let's call it, well, my favorite letter is K. Let's call it K of X. Just so that, well, okay, let's not. We don't usually say Y equals, but we would say the limit as X goes to negative infinity of negative 2 times x plus 3. To be honest with you, I don't think we need this extra set of parentheses, but it's not going to hurt. If it had been something like the limit as x goes to negative infinity of x squared plus 4x, that you do need parentheses around. Okay, so that you have to say, okay, we want to take the limit of all that kind of stuff. I just like to use the function notation because it's easier, but here we go. So this, we said it's even and it's negative, so it's going to go to negative infinity in both directions. Well, here comes, okay, I'm not going to write it. Yeah, I kind of like having that parenthesis there. We should ask a calculus teacher. And it goes to negative infinity there as well. Okay, I think he's got a little bit more for us. Right, limit notation. Oh, I kind of have done that. This is odd and positive. So the limit as x goes to negative infinity of g of x is going to be odd and positive. Means this way it goes to negative infinity and positive. And then this one, I think, did we do one like this yet? No, I think, okay, this is going to go negative infinity, negative. So it's the limit as x goes to negative infinity of f of x is equal to negative infinity, and the limit as x goes to positive infinity of f of x is equal to negative infinity also. Use a graphing calculator to determine, okay. I mean, this is just a positive quadratic. So this is going to be positive, positive. This one, okay, let's see. Here's a graphing calculator. What have we done recently on it? Other things. Delete. What did we have? We have a fraction. This was 2x minus 3 over x plus 1. Sometimes I like to change my window to be a standard. Okay, it was already, I showed up. This one is now approaching an asymptote. And so you may notice that my asymptote, if I hit exit, my asymptote is y equals 2. Okay, so as the limit as x goes to negative infinity of g of x is going to equal this positive 2. It gets closer and closer and closer to that value of positive 2. Likewise, the limit as x goes to positive infinity of g of x, it's going to be equal to positive 2 also. This one, I think what we will see, exit, we don't need this anymore. Let's delete that. That was negative 10 over x squared. It's got an asymptote at 0. And there we go. So what it's doing is it's approaching 0. So it would be the same idea except zeros. And I'm too lazy to write that. All right. Like, subscribe, comment, do all the things, and let me know how I can help you. Good luck. Go practice.